If you're in the class today, the next section of work we'll be moving on to would be the electronics section. And to start the electronics section, I'm going to take you through some of the output devices. An electronic system is classed as having three parts: an input, a process and an output. And what I've got to hand this morning are some of the output devices that you need to familiarise yourself with. Now, an output device requires an electrical input, and it transfers electrical energy into the desired energy that you want. For example, electrical to light, which I'm going to show you a couple of, electrical to kinetic, which I will show you another couple of, and electrical to sound. I'm going to start off with the electrical to light, and what I've got is a lamp. Now, the lamp, you know how it works. Switch on, current flows, lamp converts electrical energy into light energy and obviously heat. But another term that we need to, or another two terms we need to familiarise ourselves with is the type of output device that we have, in terms of it being either analogue or digital. Now, digital is classed as having two settings, either on or off, a 1 or a 0, high, low, whereas analogue has many different settings. And for a lamp, because when I change the current, the brightness changes, it's classed as an analogue device. Now also, it's a 12 volt lamp, so when working at 12 volts you can see it draws 2.1 amperes of current, and it's an analogue device. So if I change this device, so I remove the lamp, make sure the connection's the right way around. I need to decrease the voltage so I don't damage the, and switch on the LED. You will see that it lights, but you will also see, as I've just changed the settings on the ammeter, that it only draws 11 milliamperes, so much smaller current, much cheaper to run. The LED is classed as a digital device. The LED light emitting diode will not work if it's connected the wrong way around. So it only allows current to flow in one direction only, as can be seen. So that's electrical to light devices. Remove my meter and the wire and bring in the motor. So our electronic device, the electric motor, there's a tiny little piece of red thread on it that you might be able to see to try and show you, or maybe you can't see it, show you it moving. So I'll plug it in. And hopefully, a little bit of red thread, and it spins. Makes a lot of noise. So this is converting electrical energy into kinetic energy, but also I can slow it down. Too much. I can speed it up. So this is multiple settings, and therefore an electric motor is an analogue device. Another device that transfers electrical energy into kinetic energy is, oops, around, start again, is a solenoid. So it just looks like a plunger, but when you switch it on, it moves. Now it is digital, it only has two settings. It's either there or it's there, in or out, on or off. So that's the end of my electrical to kinetic. We move on to electrical to sound. So I have a little buzzer. Again, making sure I get it the right way around. It's a DC buzzer, only works one way. And as annoying as it is, you can hear it. Now this is a digital device. That's the only sound it produces. It just buzzes. However, the analogue device for electrical to sound is, I hope you can work out straight away, a loudspeaker. I switch this on, produces a sound, but unlike the unlike the buzzer, I can change this sound. I can make it a higher pitch, it's extremely loud, lower pitch. I can change how loud it is, so if I do go there, not too far, that's better. A wee bit quieter, louder, lot of vibrations. But that's the analog electrical to sound output device.